Welcome back. This is the last of the new tools we're going to introduce. So previously we have talked about interior angle sums, linear pairs, and vertical angles. Today we're going to reapply linear pairs and interior angle sums to learn about a new kind of angle relationship, which is angles that are exterior to a triangle. So in this case, what if I was trying to solve for this angle right here, and I was only given some of the angles inside the triangle? Okay, so notice if I'm trying to solve for this angle right here, I can hopefully see that I actually have a linear pair here, right? So if I knew this angle, I would be quite happy. But they didn't give me that angle. So how would I find that angle? Well, likewise notice, right, that this triangle right here is actually also forming an interior triangle sum, right? When they gave me the two other angles inside the triangle, they also actually gave me the result of what this angle would be, right? And that's the angle I was trying to find up there. So for example, if they had given me the angles, say, you know, 50 and then 9, no, not 90, um, 50 and then this would be what? 65, right? What's this one over here going to be? Well, if they had given me these two, I know by the interior angle theory, right? Interior angle theorem, that this is also going to be 65. Yeah, because it has to add up to 180, remember? And then up here, when I know this is also 65, I can then find what this one has to be, which is going to be the supplement of 65, right? So down here, I did also the supplement, but in a different way. I did, well, 50 plus 65 plus what equals 180. And I found it also had to be 65, right? It also had to be 65. And then over here, I see that, okay, well, this is going to be 180 minus 65, and that's going to get me 115. Hmm. So I'd use two things here, interior angles and the linear pair, right? Maybe it's because I had an isosceles, right? Where it had the special relationship here that we're going to discover. So what if I did this a little differently and these didn't happen to be the same angle, right? What if I changed that? So I'm going to make it instead be 70. Why not? That would make this one down here 70, 70, 70. That gets me that the question mark equals 180 minus 120, which is 60, right? Then when I put 60 over here, notice now, even when it's not going to be that special relationship that they share it, I again see, wait a second, isn't 50 plus 70 120 as we established down here, right? So when I did this one, the interior angle theory, it's like I found the supplement of those two angles, right? 60 is the supplement of 50 plus 70. And over here, I'm doing the supplement of 60. So if I got 60 with something like being a supplement, and then I do the supplement to 60, I'm going right back to where I started, which was putting together 50 and 70, right? This relationship will always hold true. So in other words, if I have a triangle and they give me two interior triangles, or angles, and I'm trying to find the exterior angle that is not touching, right? Ooh, not interior, exterior. I'm trying to find the exterior angle that is not touching. Exterior angle theory, right, is that these two, A and B, have to add up to be D. And we know that because this angle right here, C, has that special relationship where A plus B plus C equals 180, and then D plus C equals 180. So we can see that there's this connection between the two that makes A plus B plus C equal D plus C. Well, if they equal each other, right, and they're both adding the same thing to C, I can just get rid of that C by subtracting from both sides and see that A plus B equals D, right? That's what we did over here, written out as algebra, to show it's true every single time we do it, no matter what numbers we pick. Any numbers I put here for these angles will make that relationship true. Now, if I was to do this in a problem, right, it can get trickier to see that I have exterior angles. And again, you might immediately jump to recognizing, well, wait a second, I just have, linear pair and interior angle theory. And there's nothing wrong with doing it that way. It's just faster if you see you have exterior angles. So for example, I give you 50 and 70, what do I have over here? Remember, we already did this one, so we know what it's going to be, but we can still check, right? So here, when I do this, I see, well, again, I could see the linear pair, and I could see the interior angle, and I could do it the long way, or I can just see I have exterior angle theory, right? So this is going to be 50 plus 70 equals 120. Look how quick that was, right? That's all you got to do for these kinds of problems. All right, with that, your toolbox is now complete. Remember, you only really need mastery of linear pairs and interior angles. These two things, exterior angles and vertical angles, can be found by using interior angles and linear pairs. And we're going to show that in our challenge problem example, okay? But this is what I would really recommend looking over, and I would say get a mastery of this. Make it be able to do the shorthand, be able to do it quicker. It just saves you so much time and so much mental energy not having to do all that algebra. Okay? It is faster, I promise. But it can be a little tougher if you are struggle with memorizing stuff. So if you need to use linear pairs and inch angles to check your answers, go for it. Go for it. All right? So hopefully I'll see you in the next problem or in the next video where we go over a challenge problem.